Okay, so what we're doing here is I'm just going to go through the quadratic inequality stuff that we ended the class with from Monday. So what I'm going to do here is I'm just going to go through how to solve a quadratic inequality, go through the graphically solving it again. So we did this in class. Go through solving it algebraically. We kind of rush through this at the end, and also just do a couple examples just so we can see what's happening. So this was the example that we did in class. So we had x squared plus x minus 12. I'm going to do this example here where I've got x squared plus x minus 6. So the first method that we did was to solve it graphically. And so what we had to do was we had to draw out the graph. So we graphed a quadratic, which gave us a parabola. And how we did that was we found the x-intercepts. So that's this first point here. By factorizing and solving. The second point that I had in class was we checked the y-intercept. Now, this third point over here, if we're just doing it, if we want to just solve the inequality, we don't need to worry about this too much. We just want to look at the general shape of the parabola and not necessarily worry too much about this last point. And the other point that we had was we need to determine if the graph was positive or negative. So we have a look at the x squared term. Often I'll just say that we should make the x squared term positive, so it makes it a lot easier for us to, and we don't have to worry about these things. So let's just have a go at this. So these are the two main things we need to do. So the first thing I'm going to do is I'm going to find the x-intercepts of my graph here. So we're going to look at the graph y is equal to x squared plus x minus 6. And so what I'm going to do is I am going to figure out what the x-intercepts are. I'm going to factorize this. So I know that the two factors I'm going to be looking at is x plus 3, x minus 2. So this means that my x-intercepts are x is equal to negative 3 for that first term. So when I solve x plus 3 is equal to 0, and x is equal to 2 for the second term. So I've got those 2 points. Now if you have a look, that the graph here is already a positive one. So the coefficient of my x squared term is 1. That's not written there, but that's implied. Ooh. And so that's already positive, and so we've got an upwards facing parabola. So this means it's an upwards facing parabola. So the parabola is going to look something like this shape. I don't know, I haven't drawn in the intercept. So let me actually just draw this out. So I've got my graph. So I'm going to have my two intercepts. I've got one at negative 3, so that's the first x-intercept I have on here, over here. I've got the second one at 2, so I'm going to put in a dash at 2. Now I know it's positive, so all I need to do is just draw a positive parabola, and which goes through these 2 points. Now I'm not too fussed about the specific parts of the graph. If you have a look, I haven't even drawn on a y-intercept, and I don't know where the middle point of this parabola is. I don't need to worry too much about this. All I'm looking for is where's this graph above the x-intercept. So if you remember, this is the y is equal to 0 line. I'm looking for when it's above and when it's below. Those are the two main things I'm looking for. So let's have a look at what the question is asking us. I want x squared plus x minus 6 is greater than 0. So if you have a look, there's actually two regions for that. So the first region is this part over here, everything to the right of 2. So if you have a look, the red graph is above the y-axis, so I've got everything on the right there. So this region is x is greater than or equal to, or greater than 2. And I've got my other region, which is to the left of this minus 3. And so this region is x is less than minus 3. So to solve this using the graphical method, I need to draw this diagram here. I need to draw my graph so I can visualize it and I can show that I actually know what I'm doing. So to solve this inequality, I have, therefore, x is less than negative 3 or x is greater than 2. So we had to go at a similar example in class. We did this method already. I'm just going through it again just to make sure. So I draw the graph. I worry in particular about the x-intercepts, so just be careful. You need to make sure you include those x-intercepts, and those are the really important parts. And I just check, am I above or am I below? Now the second way that I went through really quickly was algebraically solving it. So to solve quadratics algebraically, I needed to just find my critical values, so finding those x-intercepts, and then I look at x values around that range. So similarly, if I had my x squared plus x minus 6 is greater than 0, I'm going to factorize the left. So I've got x plus 3, x minus 2 is greater than 0. For here, what I'm going to do is I'm just going to make a number line and look at -3 and 2. And what I'm going to do is I'm going to select values from the range on the left. I'm going to select something from here. I'm going to select a number from the middle, somewhere in here. And I'm going to select a number from the right here. I'm going to move this into the middle so just you can see what I'm actually going to do here. Now that I've done this, I'm going to actually substitute a few values in. So for example, I'm going to pick a number that's less than -3. So let's pick a number. Let's go -4. -4. Okay, when I sub it into my inequality, I get -4 squared plus -4 minus 6, which gives me 16 minus 4, 6, which gives me 6. Now, I need to then check, is 6 greater than or equal to 0? Well, that's true. So this area is true. So I know for my inequality, I'm going to have x is less than -3 for this region on the left. Okay, I'm going to do the same for my middle region. So I'm going to pick a number in between -3 and 2. Often, you might pick 1. That's totally fine. So in class, I think someone suggested that we do 1. Let me do 1 for this. I often recommend doing, if possible, doing 0. 0 is quite a lot easier, but let's do 1. So here I've got 1 squared plus 1 minus 6. So that gives me 1 plus 1 minus 6, which is -4. -4, however, is not less than 0. So I'm going to not greater than 0. So therefore this area is false, and so I don't consider this range here. I'm not going to consider this range between -3 to 2. The final bit is I check the final area, so I'm checking the region to the right of my second critical point. So here I've got 2, let me pick a number that's greater than 2, let me pick 3, so I'm going 3 squared plus 3 minus 6, which is 9 plus 3 minus 6, which happens to be 6. That is greater than 0, that's tick, and so this area is true, so my other region for my inequality here is x is greater than 2. So that's my final answer here. If you're answering this, what I recommend doing is actually just doing a few substitutions, doing similar substitutions here, and if you want, you can draw out this number line just so you can check what those 3 regions are, and just to make sure that you're picking values that are correct. And once you've done that, then you can make those conclusions at the end, as long as you show those substitutions in your answer. So let's have a go at this. Let me have a go at solving these inequations by constructing a function and sketching it. So this is doing it graphically. I'm going to do this both graphically and also using algebraic methods. So I'm going to do this with, I'm going to do the first one graphically, and I'm going to do the second one algebraically. So let's have a look at the first one. So I've got x squared greater than 9. Now here, I want to move everything to one side first. So I'm going to go x squared minus 9 is greater than 0. So I'm going to draw the graph y is equal to x squared minus 9. I can factorize it. So this one, if you notice, is a difference of 2 squares. I've got 2 squares, so x squared is a square, and minus 9 is also a square. So I'm going to have x plus 3, x minus 3. So my x-intercepts are at x is equal to -3 or x is equal to +3. Now check the sign. Well, I know that this graph is going to be positive because the value of x, the sign of x squared is positive. So what I'm going to do is I'm just going to draw my little graph. So I'm going to go whoop, whoop. I've got my y, I've got my x. I don't worry about other things, any of the other features other than my x-intercept. So I've got -3 and +3. So I'm just going to draw on my little graph here. Whoop. Whoop. Okay, cool. So I've got my parabola, and I'm looking for when this is greater than 0. Well, let's have a look at the regions where it's greater than 0. I'm looking for all the regions that are to the above the y, the x-axis down here. So if you have a look, I've got this green region over here, this one on the right. So this is on the region of x is greater than 3. And I've got my other region that's to the left of the -3, that's above the y-axis. And so that's x is less than -3. So therefore, x is or x is greater than 3. So for my first example here of x squared minus 9 is greater than 0, I've got x is less than negative 3 and x is greater than 3. So that was doing it graphically. I prefer doing this method because it's actually quite quick to do this drawing here and visualize it and check, as opposed to actually having to substitute values in. However, if you want to do it algebraically, let's have a go at doing the second one algebraically. So I've got this second example, b. X plus 6 is greater than or equal to x squared. Okay, first thing I want to do is I want to move everything to one side. I'm going to move it all to the left-hand side. So I've got negative x squared plus x plus 6 is greater than or equal to 0. Okay, I said earlier to check the sign of the x squared term, but an easier way to actually deal with this is to make x squared positive. So I'm going to multiply by minus 1 to make the x squared positive. So by making it positive, I need to change the sign of everything else. So I've got negative x minus 6. The other thing I do is if I multiply by a negative number, I need to flip the sign of the inequality. So instead of it being greater than or equal to 0, I'm going to actually have it less than or equal to 0. Okay, so I'm going to do the exact same step that I did before. I'm going to factorize to figure out where my critical points are. So here I'm going to factorize the expression. So I've got x minus 3, x plus 2 is less than or equal to 0. Okay, so my two critical values are going to be positive 3 and negative 2. So I'm going to have, so from this one over here, this is positive 3. This one here is going to be negative 2. So I'm going to put those two on. Negative 2, positive 3. Let me check a value that's to the left somewhere here. So I'm going to do negative 3. If I substitute negative 3 into my equation over here, my inequality over here, I'm going to choose that one because that one's an easy one to substitute into. So I've got negative 3 squared minus negative 3 minus 6, 9 plus 3 minus 6. So that gives me, so 9 plus 3, that's 12, minus 6, which gives me 6. Okay, now look, 6, is that less than or equal to 0? Well, that actually is not less than or equal to 0. I'm going to put a slash through that to show that it's not equal to, so this area is false. I'm going to put F for false just so I know, so I indicate that. Okay. Next bit, I'm going to pick a number in between. I'm going to pick an easy number in between negative 2 and 3. So I'm going to pick 0. Okay, so I substitute 0 in. So I'm going to get 0 minus 6, which gives me negative 6. And that is less than or equal to 0. So that's a tick. So this area is going to be true. So for my inequality, I know that any number between negative 2 to 3 is going to be true because I've tested those critical values. Okay, so I'm going to put here. So therefore, negative 2 less than or equal to x, less than or equal to 3. So if you remember last time, this was written for our absolute value inequalities. So when we had absolute value inequality, if we were looking for the area between these 2 points or underneath the horizontal line, this area here, that was this similar inequality. We wrote it as a similar inequality. Okay, final bit, just to check, I'm going to check a number that's greater than 3, so I'm going to pick 4. So I've got 4 squared minus 4 minus 6, so that's 16 minus 4 minus 6, which happens to be 6, which is not less than or equal to 0, unfortunately. So this area is false. So our final answer for this one here, I'm going to have negative 2 x is between negative 2 and 3. That's what this inequality at the bottom tells me. So that's our two methods. As I said, I prefer doing the first method, so graphing it, so we can actually just see it because it's quite easy to graph it and see what's actually happening. But if you prefer just checking a few values and doing a few substitutions here and there, just to check points, that's also cool too. So this method is our algebraic method that we just did. Hopefully that made sense. If you have any questions, please ask me in the following lesson. I'll be more than happy to help you.